Welcome to Untitled Academy. This is Richard Tai. Today is our 28th lesson of trigonometry. We have been working on graphs of trigonometry functions for the past several videos, several lessons. Last lesson we talked about how to sketch a sinusoidal function. So today we're going to continue that. So if you remember, the general form for a sinusoidal function given to us will be f of x equal to a sine or cosine bx minus c plus d. So this is the general form that we are using, which a represents the amplitude, absolute value of a represents the amplitude, b actually gives us the frequency and period, c actually gives us the phase shift, and d gives us the vertical shift. So last time we showed a few examples where how A and B changes things, and so today let's go ahead and see how C and D changes things. But let me go ahead and write all the things that we have to do, all the things we need to know, we need to identify. Okay, so the amplitude is the absolute value of A, and the period is equal to 2 pi over b. That's for sine and cosine, okay? Because sine and cosine has a base period of 2 pi. So when you do 2 pi over b, you will get its actual period. And the frequency is the reciprocal of that, so it's b over 2 pi, okay? And the phase shift is equal to c, and the vertical shift, or the midline, is equal to d. Now, one way we use c, actually phase shift is not just not exactly actually I should say phase shift is not just c, it's actually c over b. Okay, so let me go ahead, rather than writing that, let me go ahead and write this as the beginning of a period. The beginning of a period is very important, is where c over b is. So the actual phase shift is c over b. Now, I should have said the last video, I think. So please pay attention that the beginning of the phase shift actually is c over b. And where does that period end? Ending of the period, where did that period end? It's going to be c over b plus 2 pi over b, which is the period. Okay, so c over b is where the beginning of the phase starts. But as you know, we don't really have a beginning and the end for sine or cosine graph. But this is a reference point. This is a good reference point where we should start. Usually we start with the center. We start with 0. When c is equal to 0, then we start with 0. But when c is not equal to 0, then we have to start somewhere else. So this will give us a good idea where we should start on the first period, and this is where we start on the first period. Then that will give us a good idea how to graph it. So let's look at some example. Alright, so let's do some very simple example here. So let's say sine x, let's graph sine of x minus pi. Okay, sine of x minus pi. Alright, so at this case, okay, we can identify our A. A is 1, so the amplitude will be, absolute value of that will be 1. B is also 1, so okay, we don't have any change in frequency and period. C happens to be pi, and D is equal to 0. So now we notice that there is a phase shift. Phase shift will be pi over 1. Okay, so let's identify the beginning of our period. Okay, of the beginning of the period. Well, it's going to be c over b, so it's going to be pi divided by 1, so it's going to be pi. So that means our period is going to start with pi, our period of a sine, and where would they end? The ending of the period is also affected by c over b, so and the period 2 pi over b, so it's also affected by both c and b here. Now, because b is equal to 1, so in this case we're going to start with pi. This is pi plus 2 pi, so it's 3 pi. So that means we're going to start with pi and there's 3 pi. Okay, so let's see how we're going to graph it. I'm going to make it a little longer so we can graph 2 periods of it. So this is x, this is y. Okay, so let's go ahead and make pi here, 2 pi, 3 pi. Okay, I probably have to make it a little longer here. About 4 pi, and that's about 5 pi. Okay, Alright, so I think that's good. Now the amplitude is 1, so I'm just going to mark 1 and -1 here. It's going to be 0. Alright, so usually signs start with 0, and then remember what we said is, how do we start? We mark the beginning. Okay, so our beginning is pi. It's started with a midline. Our ending is 3 pi, so it's going to end at midline. So we're going to divide the first period into four parts, 4 equal parts, quarters. First quarter, second quarter, third quarter, fourth quarter. Okay, so this is going to be 1.5 pi, and this is going to be 2.5 pi. So sine, because this is a positive sign here, positive amplitude, so not positive amplitude, I'm sorry, positive coefficient, so you will go to the positive first, then you will come back down in the halfway through, 3/4 way through, you will go down. So this will be the first period of this graph, and then this pattern will repeat for the second period. So the second period starts at the 3 pi, and ends at 5 pi, excuse me, because the period is 2 pi. So it will follow this pattern as well. So it will go up, come back down, come back down here. Now mind you, this continues, keep going, so this, and then here he also keeps going in this direction as well. It doesn't mean that it ends right there, but this is a very accurate sketch of this sign of x minus pi. It means there's a shift. It means we shifted actually pi units to the right. If you can see, because usually a regular sign starts with 0 and go up to 1 quarter way through, but now we start from pi and go up to 1 quarter way through our periods. Okay, but quarter way through our period, and our period is still 2 pi because we haven't changed any period, because b is equal to 1. So we're gonna next we're gonna do an example when b and c both are not equal to 1. B is not equal to 1 and c is not equal to 0. Okay. Alright, so let's take a look at this graph. F of x is equal to 2 cosine 3x minus pi. So let's go ahead and identify everything. So a is equal to 2, so amplitude will be the absolute value of that. Okay, b is equal to 3, the coefficient, and c is equal to pi. Okay, there's no d. Alright, so the amplitude is equal to the absolute value of 2 is equal to 2, and the period will be equal to 2 pi over 3. Okay, so that's going to be an important number. Alright, now where's the beginning of the phase? Beginning of our phase shift, beginning of the period. The beginning of the period is c over b, right? So c is pi divided by 2 pi over 3. B is 3, so it's pi over 3. So we're going to start with pi over 3. And where would our first period end? Ending of the period will be c over b plus 2 pi over b plus the period. So it will be pi over 3 plus 2 pi over 3, and that will give us a 3 pi over 3, so it will end at pi. So that means our first period will start at pi over 3, and the e will end at pi. So that means our period is different, and our phase shift is different. Everything's a little bit different now. So I'm going to go ahead and do this. Pi over 3, 2 pi over 3, pi, right, which is 3 pi over 3, and I'm gonna do make another more settings. So this is gonna be 4 pi over 3, and this will be 5 pi over 3, and that will be 2 pi. Okay, so I might not use everything, but we just want to go ahead and mark it. Alright, this is your y value. So I'm gonna mark 2 here because I know my amplitude is going to be 2 to -2. Okay, amplitude is 2 right here. Okay, now cosine, so we're going to start with pi over 3. Now I shouldn't mark on the midline here because cosine doesn't start on the midline, right? Regular cosine starts on the maximum. So it starts at maximum, and then it ends at the maximum. Okay, so halfway through it goes to the opposite, go to the minimum. But okay, I forgot to mention that we got to remember to divide the whole period into 4 equal parts, right? This is the first quarter, second quarter, third quarter of the period. So from pi over 3 to pi, I need to divide them into 4 equal parts. Halfway through, of course, is 2 pi over 3. This is halfway between pi over 3 and 2 pi over 3, and this is halfway between 2 pi over 3 and pi. Okay, so basically that's 1, 2, 3. That's 3 pi over 6. That's pi over 2. Okay, 3, 4, 5. That's 5 pi over 6. Okay, usually those when we deal with common sine cosine functions that which we can graph, usually the angles will come up to be quite straightforward, and in this instance, all the angles here, all the markings here are part of our unit circle markings. All right, in any case, so cosine will look something like this. So let's do a smooth curve. Okay, smooth curve, trying to connect them like this. Okay, all right, and then you will have the same thing from pi to 5 pi over 3. Okay, let's mark the minimum here halfway through, and at pi over 3 I'm going to come back to the original, and then a quarter way through it will pass through, a quarter and 3/4 ways through it will pass through the midline. So try to make a smooth curve as much as possible, and I know this curve will continue. This will continue to the left and continue to the right. Okay, so this is what 2 cosine 3x minus pi would look like. And so in terms of shifting, you can see the amplitude increases to 2, the period decreased to 2 pi over 3, which means frequency increase, and then there's a phase shift. The actual phase shift is equal to c over b. So I want to go ahead make sure I mention that phase shift is c over b. Okay, so in this case is pi over 3. So the pi over 3 is the phase shift. Originally it was negative. Okay, it's minus, so the phase shift is actually positive. Pi over 3 is to the right, so they shift pi over 3 to the right. Alright, so let's try to take a look at another example here. Alright, so this function now we're taking a look at everything when we have everything going on here. So it may look a little bit complicated, but let's go ahead and identify everything step by step. Okay, so we have a equal to -4, okay, b equal to 2 pi. Pay attention, this is 2 pi, not 2 pi x, but it's the coefficient of x is 2 pi. c equal to -6 pi. Now why is that true? Because remember the formula we originally have is bx minus c. So in order to for our equation to fit the formula, our c has to be the opposite of this number, which is 2 pi bx minus c. So when we subtract a number c that fits in this formula, it will be -6 pi. Okay, alright, and d is equal to -3. So we have actually every kind of shifting going on here. So amplitude is equal to absolute value of -4 is 4. Okay, now this -4 will come to play a little bit later, so we got to pay attention. The period is 2 pi over b, which is also 2 pi, so it's equal to 1. So that means we are graphing every period. It takes 1 unit to complete 1 cycle. Okay, the frequency is equal to the reciprocal of 2 pi over 2 pi, so it's also 1. Okay, so it came out to be the same because they're reciprocals to each other. Okay, so the phase shift, the beginning of our units is going to be -6 pi over 2 pi, so it's going to begin at -3. Okay, and the ending of the period, the beginning of the period is -3, the ending of the period is the c over b plus 2 pi over b plus the period, right? So it's going to be -3 plus 1, so you will end at -2. So our first period will start with -3, and then you will end at -2. Alright, and now of course there's a vertical shift. I forgot to write. Vertical shift is equal to -3. Okay, so that means our whole graph, there should be a midline down at -3. Okay, alright. So this is our x-axis, alright. This is our y-axis. Now first thing is, let's mark the midline, okay, because the midline is not 0 anymore. So that's -1, -2, -3. And from the midline, okay, I have to be able to go up 4 or 5 units, 4 units up either way. So let me go ahead, mark it a little bit small. 1, 2, 3. Okay, so from my midline, I have to be able to go up 4 units and go down 4 units either way. 1, 2, 3. So this is -3 is our midline. So I'm gonna do this. I will use a dashed line here to mark my midlines. So that way I know where's my center gonna be. Okay. So this is my midline. y equal to -3, whereas that's the come from D. Okay, so this is going to be our center. We're going to center on this rather than center on the x-axis. Actually, yeah, I made a mistake because we should have. I need to start at -3 on the x-axis as well. Okay, so I do apologize. Let me go ahead. Let me go ahead and start again. Okay. So go ahead. So I'm gonna put this up there. Okay. Yeah, I should put the axis in the middle here. Yeah, there we go. So we have a little more room here to graph. Alright. Alright, so -1, -2, -3. This is -3, -4, -5, -6, -7. I need to go down to -7. Go down 4, up 4. Alright. Now on the x-axis, what I will do is I will make my spaces a little bit more. -1, -2, -3. I'm gonna make -3 here. Now notice I'm not using pi anymore. Okay, I'm not using pi in this case. Alright, so let's take a look at this. Now again, I'm going to mark the midline here. Okay, let's mark the midline at -3. That's going to be the center of our graph. Okay, midline y equals to -3. Alright, so we know we're going to start with at -3, and we're going to go to -2, right? So from -3 to -2, we're going to cut into 4 equal intervals, 4 equal subintervals, which is a quarter each. Okay. All right. Now cosine usually starts on the maximum. All right. But here is a -4 in front of cosine, so this time cosine will start in the minimum. So at -3, you will start at the minimum, which is -7. All right. This is 1, because -3 minus 4 is -7. So cosine will start right here, and midway through it will go to the maximum, which is the opposite end, and then when I complete the first period, it will come back to the minimum. Now halfway between, a quarter way, right? Quarter way between these two, I will go ahead and mark the midline and mark the midline. So this will be my first period. Now this will be look very sharp. So okay, I didn't do too well. I didn't trace too well. So I'm trying to trace a curve, trying to maintain a curvature thing. Okay. Now between -2 and -1, I can do the same thing. Mark halfway through, quarter way. So make 4 divisions, 3 divisions, 4 equal divisions. Halfway through, you will go to the opposite end, but when I complete the period, I will come back to the same side where I started, and then halfway between those, a quarter way, it will pass through the midline, because that's what cosine is. Cosine does that. Okay, as you can see, I didn't try not to make straight line, but yep, try to make sure you have a some kind of curvature here going on. Alright, so that's 2 periods of that graph. So as you can see, this is a little bit more complicated, but it is not impossible to graph as long as we take it step by step. Okay, you take the amplitude, you take the period, you take the phase shift. The phase shift is C over B. Again, C over B, that's where the first period starts, and then you take care of the midline. So start with the midline. Okay, mark the midline and then make sure that's your center. And remember the pattern for the regular cosine, with a negative sign in front of it. So basically we start from the negative, and then you can follow the pattern through, and you'll be able to graph it. Okay. All right. So if you have any questions and comments, please leave it on the comment section, and hopefully we'll go ahead and continue to learn more about graphs, and in our next sets of lessons. We'll hopefully see you join us next time. Thank you.